Okay, so here's the first question you asked about, number 5. You want to obtain a sample to estimate the population mean. So I just took this equation straight from the notes and from one of the videos on our Blackboard page. This is telling you the sample size you want when you're looking for the mean and sigma is known. Okay, so we have z, sigma, the margin of error, or how close we want it to be, and then obviously squared. So we're just going to find out all these values. So the first one's going to be z of alpha over 2. And that's going to be the z values that cuts off the middle 90%. Let me start by drawing my normal curve, like that. This is z, so the middle here is 0. So I want to know what this z value is, or this z value. It doesn't matter, just one of them. This is basically negative z. That cut off the middle 90%. So 0.90. So I'm going to use the inverse normal to find that value. Second distribution, inverse normal. But now the area to the left of the z value is not 90. It's going to be 90, and these are each going to be 5, because 90 plus 10 is 100. So this is going to be 5%. So the area to the left is going to be 0.95. Mu is 0, sigma is 1, because it's a z value. It's the standard normal curve. So this z value is going to be 1.6448 or 1.645. So we'll say 1.645. It says do not round anything, so we're actually just going to use that value from our calculator. But I'm just writing it down so we know what it is. Sigma we have is 28.5. It says you want to be 90% confident that your estimate is within 1.5 of the true population mean. So E is going to be 1.5. So we have everything we need. I'm going to do z of alpha over 2, which is this, times sigma, 28.5. Oops, 28.5. Divided by 1.5. And now I have to square that. Take that answer, and whoops. Take that answer, and square it. I get 976.7. Even if this was 976.4, you always want to make sure your sample is large enough. So if you round down, it might not be large enough. So no matter what decimal you get, as long as you get a decimal, any decimal, round up. So this is going to be 977. Okay. Next one here says, in a survey, 18 people were asked how much they spent on a child's last birthday gift. The results were roughly bell-shaped with a mean of 44, standard deviation of 8. Find the margin of error at 90% confidence level. So let's just start by finding the confidence interval. So that's just going to be straightforward. We're going to go to stat. We know sigma, so we're going to do a z interval. So we have sigma is 8. Oh, this is based off of the sample, so that's not sigma. So we can't use the interval. We have to use a t interval because we don't know the population standard deviation. You just know the sample standard deviation. So we have x bar. The average is 44. S of x, the standard deviation of the sample, is 8. Number of people in the sample was 18, and our margin of our confidence level is 0.90. We're going to calculate that. Now I'm going to write down this interval, 40.72 up to 47.28. You might remember from before, I think we did, I think we were talking about confidence intervals before, where you could write them as an interval like this, or you can write them as like x bar plus or minus something. Okay, and it was like z of alpha over 2 times sigma or something like that. This thing here is considered our margin of error. Okay, so we can figure out what that's going to be by just doing some math with these two numbers. So the middle of these two numbers is going to be our point estimate. So how do I find the middle of these two numbers? I'm going to take the average. So I'll just take those two numbers, 47.28. Oops, stupid thing. 47.28 plus 40 0.72. Add them together, divide by 2. I get 44. So 44 is a smack dab middle, which makes sense because that's our X bar. That's the mean from the sample. So then, all right, I'm taking 44, which is my point estimate, and I'm adding and subtracting something to it to get this number and this number. And that's my margin of error. Okay? So I'm just going to figure out, well, what number am I adding to get 47.28 or subtracting to get 40.74? We'll just take either one of them. I'll take 47.28 and subtract 44. So this is going to be 3.28. That's my margin of error. You'll see this pop up a lot when the election results start coming in. They'll start, or even when any of the polls start coming in, you'll see they'll give some prediction as to the population. At the bottom of the screen, you'll see a little explanation of what the poll means, and there's this little plus minus. That's the margin of error. When they say the results they're still within the margin of error, that means it's too close to call. So that's what they're referring to, is this plus or minus thing. So that's going to be your answer here, 3.28. And the last one says if n is 30, x bar is 33, and s is 16, construct a confidence interval at 98% confidence level. Assume that that is not a distributed population. Okay, the important thing to notice here is that they didn't give us sigma, they gave us S. So S denotes it's coming from a sample. Okay, so when we don't know sigma, we have to use a t-interval. So I'm just going to go back to my stat list, over to my tests, down to t-interval. I'm inputting data. X bar is going to be 33. S of x is 16. N is 30. And my confidence level is 0.98. Calculate. And I'm going to get 25.8 for one decimal, up to 40.2. And that's it.